Hello, everybody. Thanks for joining. Welcome to the Storage and Cinegy webinar, where I shall be talking about storage and how we use it in Cinegy, and give you some idea of what we use, where we use it, and how to think about storage when you are planning a Cinegy installation. So, without further ado, let's have a look at what we're going to be talking about. I'll begin with a simple introduction, it won't take long, and then some basic storage principles that should always be borne in mind. And then I'll do some talking about storage arrays, and then get into detail with the storage requirements for Cinegy Archive and News, for Cinegy Capture, for Air. And then I'll have a quick word about cloud storage, and finally, what's coming in the future in terms of storage. So, storage then and now. Now, because I'm incredibly, unfeasibly old, I've been in the computer game now for a long time, in my 5th decade working with computers. And as a result, I can remember how it used to be. And this is an example of how it used to be. The very first hard drive I ever used was an IBM AT in 1985. That hard drive was 20 megabytes, and it cost then £2,000 sterling. The price per megabyte, therefore, was £100, which would mean that a 1 terabyte drive at the time, or 1 terabyte of that storage, would have cost £100 million sterling, which is close enough to 100 million euros, really. But it's an insane amount of money, whichever way you slice it. Nowadays, you can buy a 16 terabyte single drive for around 400 euros. This means that your cost per terabyte for that drive is around 25 euros. So what we've seen year on year is a 35% per annum depreciation. Every single year, cost per terabyte has dropped by a third. Now, it's gone down by more and less over the years, and right now, year on year, it's not dropping to the same degree. But this is intended to communicate a couple of things. The first is that a storage system is never an investment in purely hardware terms. The storage is merely how you keep the information, the data, and the data has the value. And this is the operative principle that you need to be working on. If you think too much about this stuff, it will drive you crazy. At the end of the day, the value is in the data, not in the hardware. So the fact that the hardware is going to change on you is really irrelevant. You get what you need right now. Waiting for tomorrow, it may well be cheaper, but by then you'll need to store more anyway, so you'll end up paying the same amount. I'm joking, of course. So for types of storage, as we think of it in the storage world, that is for a large part of my background. First is, if you're sitting at a machine, what is the storage that you will typically have in front of you? And the answer is DAS, online and offline. DAS stands for direct attached storage. That means disks which are physically in the machine that you're sitting at. And clearly, in any one machine, you're only ever going to be able to put in a finite amount of disks. Even though they're big disks, and even though you can get quite a lot of them in there, at a certain point, you can't put any more in. So that's the first disadvantage. The second disadvantage comes from a commercial point of view. And that is, as long as people are performing work for an organization on local storage, the data that they are using is limited to local storage and is therefore not under anybody's control. And if that person isn't there on a day to get the information, then it's locked up, which leads us to storage type 2, online storage. Now, online storage consists of some kind of set of disks which are stored somewhere else on the network and which you therefore access via your network connection. Now, this is a better situation as far as enterprise data goes, because all the enterprise data now lives centrally, can be supervised, can be backed up, etc., etc. In addition, the amount of space can be allocated per user to ensure that they have enough to do their work, but as much as they need. And also storage arrays or network storage usually is tied in to the operating system, which builds in security, permissioning, and a bunch of other things which are very useful to have. So online storage, usually active live disks, and they are in a variety of forms, and we'll be coming back to that in more detail later. And finally, we have so-called offline storage. Now, in offline storage, the content is there, but it will need to be fetched before it can be used. Classic offline storage is a taped library. In modern times, there are newer disk-based archiving systems that are also available. At the end of the day, disk-based archive has the advantage of faster response at a higher cost per gigabyte. Get the one that suits you. There are also other offline storage possibilities nowadays, and again, I'll be touching on some of those later on. The actual storage units, what gets written to, is in the next line. That is to say, be written to disk, to tape, SSD, and then it says SAS and SATA. So how does this all boil down? Well, your disk conventionally and traditionally will be a hard drive, which consists of a number of platters made of glass or steel with a recording medium on them, which used to be ferric oxide, which is why us old storage types talk about spinning rust. The upside of these is that over the years and with efficiencies and so on, the amount that they can hold has grown immensely, at the same time as the price of purchasing them has dropped, as we saw on the previous slide. The disadvantage, and it will always be there with hard disk drives, is that they are mechanical in nature, and mechanical devices are subject to risk. The spinning platters are read by a little head that hovers over them, and this little, like a record player. If this little head should, through any set of circumstances, that accidentally come into contact with one of the platters, that's called a head crash, and bad things will happen. Additionally, the motors, servos, etc., in the system are driven by firmware, so if the board fails on the disk, that will also cause you trouble. So you will want usually to try and ensure, if you're using spinning disks, that you have more than one copy of the data, which is where the tape comes in. Tapes are nowadays pretty much, for our purposes, we can just talk about LTO. There have been other tape formats over the years, but LTO has pretty much come through as the most useful format. It spools at a decent speed. It can hold an incredible amount of data, and if you use it carefully, it can also be reasonably responsive. So it's not going to go away, although certain disk vendors would very much like to say, oh, we don't need tape anymore. It's still there, and when we talk about the BBC in Northern Ireland, it will give you a good idea of why it's still there. SSDs are the new thing. Well, new is an interesting way of putting it. When you're as old as me, everything is new. The idea of the solid-state disk is that it is, instead of being made up of spinning platters and being mechanical, it's discrete. That is to say, it's electronic. Instead, it's made up of memory cells, which can be written to and read from. And these memory cells, because they are in a non-moving thing, are reasonably robust. Your risks with SSDs have to do with things like the way they wear out. And the way that they have been known to wear out is that the cells will no longer allow themselves to be rewritten. This has at the beginning, at the outset, this was seen by many people as a possible risk, but with time and improvements and careful design, it has been considerably reduced, to the extent that one array manufacturer ran a test on a year's use of SSDs in an array and reported that in that time the SSD had used about 2% of its life. So the old fears of SSDs are disappearing. What remains is the relatively high cost per gigabyte, right now sort of around 4 times the cost of a disk. If we look at the devaluation that we just saw, a quick bit of mental arithmetic will identify that yes, you were paying what you pay for SSD now a few years ago for spinning disks, and those spinning disks will more than likely die quicker. So nowadays, SSD is a very serious contender. It is very fast. It is, let's say, easy to maintain. It's a coming thing, and certainly, from our point of view now, there is absolutely no reason anymore to boot a machine off a spinning disk. Nowadays, booting off SSD means that you go from switching on to Windows in half a dozen seconds, in my case. And yeah, I'll take that. Then the other two, SAS and SATA. A question we get asked a lot: which should we take, SAS or SATA? Well, the answer is, what do you need? SAS disks. This is serially attached SCSI. SCSI used to be the king of storage connections back in the 90s, 80s and the 90s. When Apple started connecting hard drives, they didn't use the clunky system that IBM did. They went for SCSI, which at the time was reasonably new, but costed a lot more to implement, but was one of the magic things that made early Macintoshes such an attractive thing. Modern SCSI is, instead of being on this rather fragile parallel connector through an expensive cable, nowadays you can drive SCSI disks through a serial connection, hence SAS. So SAS disks are small and fast. SATA is a different approach. It allows for much more data per disk at a slower read. So although that inverted commas slower is in our neck of the woods not such a big deal, if you have SATA disks in an array, you can usually get enough throughput for a lot of our applications. Nonetheless, the bottom line is, if speed is going to be a criterion, then you are looking at SAS disks. If it's going to be capacity overall, then SATA is a good suggestion. Also, from the point of view of budgeting, you can probably build something around SATA cheaper than you can build something around SAS. So next line, RAID and JBOD. RAID is the redundant array of independent disks, although when I first read the white paper, because I'm old, it said redundant array of inexpensive disks. Brilliant idea. Back when this was first thought up, really large storage capacities tended to be in very, very big boxes and cost a great deal of money, practically hand-built. And so small disks were initially seen to be very, very useful, but in practice, their capacities were limited, and they were not built to the same standard as the big disks. So some clever chaps got the idea together to say, okay, if we put in 5 disks and we have one of them that keeps check data for the other 4, then we've got 4 disks worth of storage that looks like a single disk, and it's secured. Okay, so that's the idea behind it. And as time has gone on with increasing disk sizes and various other things, the initial impetus or requirement for RAID has kind of gone away. And so nowadays it is still there. It tends to be in the background. You don't tend to have to worry about it so much. And frequently also nowadays it's implemented in software rather than hardware. And I'll be coming to what that means on a later slide. The next thing, JBOD, is a RAID without a RAID controller in it. So instead of the disks being stacked together and one of them being in charge and etc., they're just disks. JBODs have the advantage, though, that you can hook those disks up to a PC, and then you can use the PC to control those disks, either deal them out as single disks or make them into arrays, say 2 equally sized arrays, and then you mirror that. So you can basically you get half the capacity off the box, but if anything fails, you can immediately switch over to the other copy. This works faster than RAID. If a drive fails in RAID, then the system will reconstruct. And while it is reconstructing, there will be a performance hit. This is absolutely unavoidable. If you mirror, that's to say you have 2 identical copies being written simultaneously. If you need to switch over, you can switch over immediately because you've immediately got a full copy of the data on the other side. And again, I'll be coming back to this a little bit later on when I'm talking about RAID and stuff versus redundancy and backing up and all that kind of stuff. Finally, NASs and SANs. NAS, network attached storage. It means that you have a pile of disks in a box with an operating system driving them, and that operating system will make the disks available as prepared volumes with a file system. The file system, excuse me, is yours to choose according to your requirements. If it's almost always going to be CIFS or SMB, as we call it, the Microsoft flavor. But there's also NFS. As an old man with lots of Unix history, I like NFS, but that's because I'm old. So network attached storage delivers something. You plug your PC in, and there are your files, and it's very good. SAN is another thing. Now, SAN is actually something where I would say, listen, we really don't need it. We don't. I mean, it's and for that I'll go to another slide. Of course, it's up to you. Please, it's your money. The good thing about SANs is that they can now achieve quite incredible data transfer speeds. So from that point of view, it's like pretty amazing. But they achieve those. It's a bit like, you can do 500 kilometers an hour in a passenger aeroplane, but it's really there for transporting passengers. And SANs work the same way. They're really there for supporting large numbers of users in enterprise environments. They're for driving databases, big Microsoft Exchange setups, that kind of a thing. For our kind of work, using a SAN for a Cinegy database, even the biggest ones, is extreme. And I mean, as I say, you can do it, but you don't. It's your choice. The other things that you have to bear in mind, it's more complicated to set up than NAS. For best performance, it requires fiber, although you can run it over copper if you want. You're going to need at least one additional server. Your NAS has the server built into it, whereas for a SAN, you're going to need a SAN server, and that SAN server is then going to need to be stuffed with at least one fiber HBA host bus adapter to talk to the disks. Fiber disks and HBAs are expensive. And at the end of the day, as I say, this is designed for large-scale transaction workflows. This is designed for tens of thousands of users. It's really not an appropriate fit for what we do. So to generalize on what we need, first thing to say is that Cinegy requires no special drivers, file systems, or helper apps. You're not locked in with our stuff. You can use whatever is available in the marketplace to work with Windows. For archive, really, at the end of the day, your only need is capacity with an eye to throughput for transferring stuff. But with capture and air, you're looking for capacity and throughput. And for all of our other applications, for just system disks, you can use whatever you like. But like I said, nowadays, you probably boot off an SSD. So, basic principles for a NAS. If you're going shopping for a NAS, there are some things that you may need to know. The first of these is raw versus formatted capacity. Now, storage arrays tend to break their disks up differently from regular disks. So the first thing is the actual disks themselves in a storage array will frequently hold less data anyway, because they will have a certain part of the disk which is partitioned for their internal purposes. So usually you're already losing something. In addition, if you are using various other things that you can use to, for example, snapshots and other things like that, and also the RAID level that you choose. Well, all of these things that will play a role in the actual size. And then finally, those disks have to be formatted with a file system, and the file system never fits to the edge anyway. So the bottom line is, if you're looking out to set up a system and you're ready to go shopping for storage, and you go looking for storage, the ticket number, how much storage is in an array, is always the empty disks that are in it, and it's very misleading. So you want to be absolutely sure that your formatted capacity is going to be adequate. The raw capacity is meaningless in this sense, so that's something to bear in mind. Then speed. Now, speed is a question of, what do you mean by speed? There are all different ways of looking at speed. There are three ways that we're looking at it in this environment, and they are throughput, IOPS, and latency. So throughput and IOPS are together because they're two sides of the same coin, only the other way. Throughput is all about getting as much data off the disk as quickly as possible. IOPS is all about getting as much data transactions onto the disk as possible. This means that they have two completely different requirements, and you would configure your system differently for if you're putting the database on it from if you're media storage in place. SQL Server, which we use, has the possibility of splitting its components over different disks for backup and management purposes. This is the role of the SQL Server administrator, who will then ensure that your SQL Server system delivers comprehensively. It's a very useful person to have in a larger installation. Just don't ever let him touch the tables. Latency is the amount of time that it takes to request something and have it returned. So the actual delay between the call and the response. In modern storage arrays, in our environment, latency is, if the array is correctly configured, latency should not be an issue. If you are seeing latency, then you would look at the configuration of the storage as the first place that you would go looking for it. And then finally, issues of reliability. I mentioned RAID. Now, RAID is, as I said before, you have 5 disks, you make one of them a watchdog, and then if a disk fails, then you can replace it. I mean, there is a whole bunch more to it, but I could talk about this for hours, and we'd all be asleep, and we don't have hours, we're not going to. The biggest thing that I want to say is this: RAID is not a secure solution in the sense of it's not as good as a backup. You will still, even if you've got RAID, even if the guy sells you RAID, say, hey, anything goes wrong, pull of this, put a new one in, it's all good. And the bottom line is RAID will repair rubbish data just as easily as it will repair good data, and therefore does not constitute any kind of a backup. So you are always going to need some kind of a backup along with your NAS. As long as you keep these things in your head when you're looking at NAS, it will help to point you in the right direction. This is the throughput versus IOPS slide. Now here we can see on the columns, the red and the blue columns indicate IOPS, which is optimal for database operations. And as you can see, down at the bottom, we have the block size going from 4 kilobytes up to 1 megabyte. As the block size increases, the IOPS go down. And there's an explanation for that on the next slide. But as the block size increases, the transfer rate goes up. So for your large media files, you're going to like large block sizes because that will give you an optimal delivery throughput in return. On the other hand, if you're setting up network storage for the actual database files or for your SQL server, then you're going to be going more to the smaller block size because the smaller block size is far more efficient for a database. I'm going to skip 2 slides to go to this. I'll come back. This is the, I put the slide in the wrong place, that's why. So here, this is from our documentation. This is from Open, talking about Cinegy Archive. And although there's a lot of words on here, but the important bit is in the final paragraph. The data that's written to a database in general does not exceed 8K per write. So formatting a volume with 64K block size for use with the database is counterproductive. It's very, the point that I'm showing this was, the reason that I'm showing this was to display that information and also to point out that there is useful information within our documentation that can also help you here. A lot of what I'm telling you is from our documentation as well as experience. So for the database side of a Cinegy Archive setup, you would handle things differently from the media side, and that's why we give the possibility of splitting these things out, which I'll talk more about in a second. This is all going back. There we go. I'll go backwards, not forwards. So about the storage arrays that I've just been talking about. There are the big boys. These are the Gartner top guys and the biggest sellers and yada yada yada. You're looking at Dell EMC, Hitachi, IBM, NetApp, and some others, Huawei, and yeah. With these systems, when you go to buy one of these systems, your price per terabyte is well considerably more than the 25 euros that I was talking about at the beginning. 10 times that is not unreasonable. But you are not buying discs from these guys. You are buying peace of mind. And that is something that is in a broadcast environment, I think, has considerable value. The peace of mind is that if you have a large storage array from these people, then you can set up monitoring and maintenance systems with these people that can be more or less hands-off if you like. Hitachi used to have a thing where they wouldn't even let you know that one of your disks had failed. Their machines would report to them. And if a disk was dropped, your man would turn up from Hitachi and swap the disk, and the users would never even know that it had happened. I think they're a bit more open about it these days. The idea was back then, you know, it was a good way of hiding how reliable it was. But at the end of the day, if no harm was done, it's all okay. So when you buy these, you are buying shelves of disks, you are buying a controller. You have the possibility for clustering, that is to buy 2 stacks and connect them together and allow them to replicate. We do not think necessarily that that's a good idea. Replication, like RAID repair, will replicate rubbish data as easily as it replicates good data. We would say, if you're going to have 2, keep them separate and write to them separately out of archive. This would be our best practice. It's in the documentation. Other choices in the array market are Zendata, Quantum StoreNext, pick up. Now, these 2 I've put side by side because there is a certain stunt you can do with those, which one of our customers has done, which we think is rather cool. In addition, declaration here, we work with Zendata, and we have a hybrid product that is Cinegy software and Zendata software that we work on together. So these costs per the Quantum StoreNext is still quite expensive. I would argue that Zendata is more competitive. But remember, I just said they're partners of ours, so you can't believe a word I say. Nonetheless, Zendata specialize in storage arrays and backup arrays and an optimized system for data retrieval, and they are also, both they and the Quantum StoreNext team have interest in media specifically as what they store, so they're very useful people to talk to. go down the price list a bit, if you go down the price list a huge way, then you'll come to the QNAPs and the Buffaloes. These guys can do you 4 and 8 disk type arrays, which with 16 terabyte disks can add up to a lot of storage. There you are in a situation with QNAP and Buffalo, you are almost certainly using SATA. I don't know if the Buffalo's got SATA in the bigger ones. You're almost certainly using SATA disks. So you may certainly get enough performance out of it, but if anything goes wrong with it, then you will be looking at hefty reconstruction if you're using a RAID type setup. Again, nothing to stop you treating these things as JBODs, making 2 separate, or essentially mirroring, split the storage in half, write to one half, mirror the other. That's always your best bet for getting stuff back quickly. We don't disapprove of this as these are storage solutions. At the end of the day, a storage solution is like a cook's knife. It will if you don't know what you're doing, you can hurt yourself, but if you do know what you're doing, you can get a great deal done. So it's definitely not off the list. The final consideration here is Linux and ZFS. Because my storage background is predominantly Linux, or predominantly Unix, I should say, to be fair, I'm a big fan of it. Linux gives you Unix, which is a fantastic operating system, and it also gives it to you with ZFS, which is a tremendous way of managing disks. ZFS is the sort of thing that you find in the big boys, but it's publicly available. You can build 40 terabytes. We built 40 terabytes with 10 gigabit Ethernet connections for $5,000 only a couple of years ago. Just off-the-shelf components and built in a day, and we were very pleased with the results. So if you can build yourself 40 terabytes for 5,000 euros, then you could build yourself 2 times 40 terabytes, have mirrored stacks, and away you go. You can therefore replace RAID and its ilk with redundancy. The big value of redundancy over rebuilding, as I've already said, that information is already there. You can simply switch to it. So you can get all of the shiny of a, for example, a NetApp filer in a ZFS appliance that you build yourself. This is serious software. At the end of the day, this is the software behind Oracle's storage. But it's freely available for you. And always, as I always talk about these things, the key thing to remember is that if you do that, then you own it. And you will have to understand it, and you will have to look after it. But given the difference in cost per terabyte, there's plenty of margin to hire somebody to do it, or anyway. So that's the possibilities in storage arrays as I see them. All we ever need is this, this is our recommendations, requirements, and suggestions all in one simple slide. All we require is a UNC path. What's on the other end of the UNC path is completely up to you. We only care that whatever comes through the network cable from that UNC path is fast enough and clean enough that we can work with it. But that's system administration that will guarantee you that. We recommend multiple arrays. This is in our best practices, and it's also mentioned in our, mentioned in our documentation. It is absolutely a very good idea to have independent storage that you are simultaneously writing to. For if you are putting in something that's based around archive and desktop, desktop will default to medium resolution editing. From an administration point of view, you may well wish to ensure that it only allows medium and lower resolution editing, which is something that you can handle in the Cinegy Archive Manager. By going for medium resolution editing, you are pulling a lot less data from your disks. You can have a lot more people working in parallel. And that's one of the secrets that allows us to have hundreds of users simultaneously working on content. The storage groups is relatively new. This is something that's come in the last few years for us, but this is our way of virtualizing your storage. It allows you, in essence, to subdivide your storage on a virtual level rather than a physical level. And specifically, it also allows you to route content to relevant areas. We think they're good, and something that when you are planning and building something around Cinegy, we would recommend that you look at that as maybe as part of your workflow. Cinegy File Service is part of the Cinegy Archive, and it will allow you to groom your content. It will allow you to find content that has expired and move it to different storage or purge it or whatever you like. It essentially, it's an automated storage administrator that runs in the background. With Cinegy File Service, you can manage your storage based on your, for example, monthly turnover. If you get through a lot of data in a month, use a lot of video for a month, and then after that month it is unlikely to be heavily used again, use the Cinegy File Service to move it, and then all your high res can be moved somewhere else and leaves you space to put more high res in. Low res usually, as my German wife would say, it doesn't eat any bread, and therefore does not probably doesn't need to be moved around so much, and also makes a useful backup, which we'll be talking about in a second. Finally, a suggestion, not a recommendation, but Microsoft DFS provides a nice interface for storage aggregation. That's to say, you can put a bunch of storage behind it. It gets farmed out to the Microsoft clients as if it's just there. But what's nice about it is that you can add stuff in the background reasonably easily without actually changing anything at the client end, and that's what makes it so useful. We've already covered this, and I'm not going to do it again. This is the storage management page. I've already talked about this, and I'm even now running out of time, so we'll go past this as well. The BBC Northern Ireland storage strategy. I never tire of talking about this because I think it's so cool. BBC Northern Ireland, a very important customer of ours, several hundred simultaneous users of desktop and archive, and lots of capture, and also very clever people, which is also nice. In BBC Northern Ireland, they have two redundant storage towers, which are kept in separate buildings, several hundred meters away from each other. They also have a quantum tape library. So the quantum tape library is only attached to one of the towers. Ingests happen straight to the tape library. That is to say, they are put onto a part of the disk from which they will be harvested by the tape library when instructed. They will sit on this piece of disk for a week because they will most likely be used up within that week. When the week is over, they will be moved from that buffer onto a tape. In archive, we still know where it is. It's got a little offline flag, and if you're using it in archive, if you do something with the medium res in archive, as we all know, when you come to move it out of archive, transform it or anything like that, it will pull the high res unless you ask it not to. According to the guys at the BBC, they've got it tuned pretty much so that high res can be pulled quite quickly. I haven't yet seen that happening, but I'm willing to believe them. Now they have found themselves a nice medium resolution that they can work with, which is a 5 megabit H.264. Now 5 megabits is clearly going to be a lot smaller than 50 or any other high res stuff, so they can use it. It's good. It's compact. It can sit on there forever. They don't need to worry about moving it off. But what they do need is every now and again they do a DR test. The DR test, because in disaster recovery, unless you have tested it, then you don't have anything. In DR test, a couple of times a year, they swap the towers. This means that the tower that is providing the content that is going to antenna does not have access to the high res. It means the only available content is low res. The BBC guys say with some satisfaction that no one has ever noticed when they've been running from high res or medium res. No one has ever noticed. We think that's a pretty smooth concept, and in fact we're so impressed that we've got together with Zendata to offer something of ours that will do the same trick, which is the Platform 1 system. Now, Platform 1 gives you a server and disks and a tape library, together with Zendata's storage management software and Cinegy Archive, all together in one server. It's a drop-in. You're still looking at 6 figures. Don't be thinking, oh man, it's going to be over 100,000 euros for a decent installation. But it would allow you to do a similar trick as the BBC did. The capture and play out, it's worth talking about. Well, the simple way of looking at it is for both capture and play out, actual full-on high speed from your storage may not necessarily be necessary insofar as we buffer. In capture, we buffer on the server and write to disk, and because that's disconnected, then the disk writing can happen after the recording has finished. It has the disadvantage sometimes of hiding problems with your storage network, but I would worry about that if it comes up. The Playout proxy cache works the other way. You're pulling from your network, and this time you're sticking it in the system. Rather than in the system's memory, you're putting it onto an SSD. We used to say it had to be an array, a stripe, multiple disks together. And the reason that we said that was because our proxy will continue to be looking in the proxy for content. And so seek times, as we call it, the time it takes for a read head to reach the data that's needed, that was crucial. And the stripe made seek times lower, and that was why we asked for it then. SSD seek times are low anyway. So you can effectively have an SSD that will handle your proxy cache, be nicely full up for you. It's fast enough to feed your playout, and at the same time, it's got the seek time to be able to find the necessary pieces. And so in both cases, it's certainly the case of we don't need a proxy disk for capture, but in air we use one. But because we are using an SSD and because of the way that we work, we have enough performance. For archive and playout, things to bear in mind. I've already mentioned downgrading footage. This is something that you is always available to you as part of a workflow. That is to say, suppose you go for our park the high res on tape and get it when we need it thing, and all of a sudden you do need something that's on tape and you need it now. You have the option to go to the medium res. As we've already said, if the medium res is good enough for the BBC, it's got to be good enough for anybody. And it's also a good way of compensating for any storage issues. And this is how we deal with online and offline assets. So given that you're going to be looking for a more flexible storage solution with archive, alternatively, you can use any old thing to store the database on and buy something super slinky for the actual media. The Cinegy structure allows you to do that. Really, it's down to you how you want to approach that. Last thing that we want to get to here is how do we know how much to store? I mean, this is fairly fundamental stuff, and also I'm not a mathematician, and it's ugly the way I've done it. But in essence, what you're looking at is you have a certain bit rate with your chosen codec, and that bit rate is the number of bits that are going to go down the pipe for any given second. Okay, so if you want to know how many kilobytes that is, then you divide it by 8 to turn the bits into bytes, and multiply by 3600 to turn the kilobytes, to turn seconds into hours. and then you know how many kilobytes per hour it's going to be. I did it that way because of all the zeros. Then you divide your kilobytes per hour by 1,000,000 to give you gigabytes per hour. And then the number of hours desired will be how many gigabytes you need plus 10%. You're always going to need 10% for moving stuff around. So our classic is 40 hours of XCAM HD fits a terabyte. How do we come by that? Well, 50 megabits divided by 8 times 3,600 gives you 22.5 billion. Divide that out, comes to 22.5 gigabytes. 22.5 gigabytes times 40 is 900. At 10% for the disk, gives you 1 terabyte for 40 hours of storage. And there you can also clearly, I mean, there is the reverse argument also applies. You can figure out when you've got so much disk, split it out like this, and you can see how many hours you're going to use. As I said, this is Mickey Mouse stuff. For me, just knowing 40 hours is a terabyte. That's enough. And if you just keep with that as a rule of thumb, you should be fine. Obviously, if you're getting out into UHD and stuff, all of this changes because clearly you're talking about a whole different level of number of pixels that need moving and stuff. But in the up to 8K, up to 1080p world, all of this stuff will work fine for you. Very quick word on the playout cache. We will take the first 100 frames from the NAS. Thereafter, the cache takes over completely automatically. If the cache fails, Playout will go straight to original storage, and there should be no visible difference. Nowadays, as I've already explained, we're talking about using SSDs instead of arrays, and we recommend 1 SSD per channel. I have proxied 2 channels on a single SSD, 2 HD channels on a single SSD, so I know it can be done, but for tidiness, 1 SSD per channel, given a terabyte SSD is $100. What do you want? But it also gives you the possibility of using SSDs instead of arrays. Suddenly, you can proxy cache 4 channels, and all of a sudden, our old strictures about how many channels you want to put on a server, as long as you can proxy them, it's that's one. So it's a good thing. Finally, the future. First off with cloud. When you install in cloud, there are essentially 3 storage options that are immediately available to you. You'll get a local SSD or a number of them that you order up with your instance. You have the option of a virtual NAS, which I have not yet tested, but we're planning for our next training. And then the S3 buckets. For a long time, we were we hadn't supported these, but now our support is there. So we can use S3 buckets for storage in Cinegy Cloud installations. Talk to our professional services guys about that if you've got that need, because they know a lot more about it than I do. Then for offline storage, we were talking before about tape libraries. Well, that's one possibility. Nowadays, you have cloud gateways that would allow you to keep a storage server on a cloud instance and simply connect to that to back stuff up. And it even extends to virtual tape library capabilities, which Amazon offers. I'm sure the other guys do as well, which would allow you to use tape strategies to write your backups to the cloud. And the last thing is now the bleeding edge. So what's the stuff that's coming that's good? NVMe, non-volatile memory express. The idea of this is no more SAS or SATA. It's a different means of plugging in. You can plug NVMe effectively. You plug the controller straight into the PCI bus without any intervening storage controller. The specification has fabric support, which would mean in the future interconnectivity of the disks to form large areas is very much there. And specifically, it blurs the line between disk and memory. We are all, those of us who work with computers, are all children of John von Neumann, who said a computer consists of processing, I/O, and storage. For storage, that model means both memory and disk, and NVMe points the way towards systems where that is the case, where non-volatile and volatile memory can be mixed for certain applications. Downside, it's not cheap yet. Although NVMe SSDs are out there and they can be, they are possible, building large-scale NVMe installations is still quite expensive. It's still more expensive than SSD. Then finally, object storage. I think object storage is a brilliant idea. Simply make oceans, well, I said pools of disks, but you end up with oceans of disks onto which you float your files as objects where your data and your metadata are in one lump that you fish out with a query. It's a completely different model from the filing cabinet approach that that's been used up to now, that basically copied from real life. It's scale out by design. You can just keep growing object pool as big as you like. And you can use it pure, that is to say, address the objects within it, or you can tack on a file system and let the object in the object storage run in the background, and then to the front end it'll look like something else. Object storage, for example, will automatically create multiple copies of all of the content in it, so that it can retrieve pieces. If something lands on a bad disk or bunch of bad disks, an object storage system will be able to build you a complete object nonetheless from either parts or a whole copy stored elsewhere within the system. All of this is wonderful, but the problem is that it's a complex setup. An object storage system is a multi-server system, needs different servers to do different parts of the storage management. It's basically, you're looking at 3 to 5 servers for a basic setup, if we talk about Ceph, which is usually the first place that people talk about object storage. So it's promising, but it's not there yet. And that's it. Thank you very much for spending your time with me today. Very much appreciate it. This webinar will be put onto YouTube, and if you're watching on YouTube, hi. For the rest, as I say, thank you very much for joining me. Address any questions, because unfortunately we've overrun a bit, so address any questions to me, Andrew at Cinegy.com, or to sales@Cinegy.com. And for the rest, I look forward to the next one, and thank you very much, and enjoy the rest of the day. Bye-bye.